This is the Team 4 Sprint 6 artifact review. Team members are Thomas, Karan, Leo, Suraj, and Brandon. We had two main goals this sprint. The first was to get the ROS system into a more functional state, trying to make sure that we have the hardware working so we can detect the inputs and outputs in that system. The other goal was to get our data set prepared for the machine learning. In order to do that, we had to annotate the crops in a set of images, and we're going to use that for our transfer learning model that we will be developing. As always, we have made contributions to our GitHub repository, and you can see some of the pull requests made over the sprint.
So today we're going to take a look at our progress on the ROS node integration. So we're going to take a look at the RealSense camera node, the Neural Compute Stick node, and also our CropRow algorithm node. And just to show you some basic connectivity and where we are with the implementation so far. But let's go ahead and start with the Neural Compute Stick. So first we're going to launch a little demo machine learning model on it just to show you how it works. Now it's not with CropRows, it's going to detect some other objects, but just to give you a basic idea of how it works, let's go ahead and launch this. Our graph is loaded, and let's now launch the demo. So what this is basically doing is taking an image as input, feeding into this convolutional neural network, and it's going to detect the objects in the picture. So as you see, it's going to, and this is all happening on the Movidius ROS nodes. You can see the topics are right here in the node. So in this case, this is just taking an image of a sink and faucet, and it's showing you everything that it detected in the image. Now we're not really sure how our model is going to be implemented at this point, but it's going to be something very similar. So that's that. Let's go ahead and kill that. Let's switch over to the RealSense. Now let's boot up our RealSense. Let's also boot up our CropRow algorithm node. And what this is basically telling us is that we're able to pull the image from the RealSense topic, do something with it, and publish it to our own topic right here. And if we open up Arvis to give us a little bit of visualization, we can go ahead and add the topic right here from the RealSense. And one second, there we go. And so what our goal is for the future implementation is to basically send the image of the CropRow to the Neural Compute Stick node. It's going to do some processing there and output it back. But right now this is just to show you the connectivity and that it's working. So let's go ahead and close Arvis, and let's also show you the graph. So as you see, this is the camera node. This is our CropRow algorithm node, and it's taking this topic right here. And in a future implementation, we're going to do a lot more with this. As a last thing, let's also show you a little example with basically with all the pieces of the RealSense, with the Neural Compute Stick. This Neural Compute Stick takes camera topic as input, and you also can specify what type of machine learning model you want to use. So let's go ahead and run this, and then we'll show you the full graph of that. So let's launch this here. There we go. As you can see, the Movidius nodelet. So this is gonna be really important for our future. This is where a lot of the processing is gonna happen with the image. And now let's launch the stream detection example just to show you how we can output that processed image. Let's go ahead and launch that. Okay, good. And now if we go into our graph, we're going to be able to see, so here we have the camera node and all the topic going on here. You can actually see this raw image is going to the Movidius. So in future implementation, we're going to be doing some processing here, detecting crop rows, and here it's going to go right back into this stream detection example. This is just to show you sort of the data flow, how it's supposed to work. And this crop row algorithm will also get integrated into this whole thing. So yeah, that's that. I hope you enjoyed the little presentation, and we hope to build on this in the future. Thank you.